Two light bulbs are hooked up to separate batteries. The probability of a light bulb continuing to work after a year is 96%. What is the probability that both light bulbs will work after 1 year? Tell me why these are independent events. Yeah, it's two different bulbs hooked up to two different batteries. So if one battery fails, it's not going to affect the other one. Good. So here are two light bulbs. What's the probability that the first light bulb works after a year? Yep, 96 over 100, or you can say 0.96. Either one's good. And what's the probability that the second light bulb works after a year? Same deal. It does not change. Or again, you can say 0.96. So this would be 96 hundredths quantity squared. As a decimal, you get 0.9216, which is as a percent, 92.16%. Notice that it decreased. It will always decrease in this type of scenario. Because if you had 100 light bulbs, this says that 4 of those 100 aren't going to work after a year. But what if you had 4,000 light bulbs or 20,000 light bulbs? How would you figure out the probability that they're all going to work after a year? Let's start smaller. What if I had 3 light bulbs? What would the setup be? Yeah, exponent 3. And 4 light bulbs, the exponent would be 4, so on and so forth. So even though the product rule is only defined for an E and an F, you can have as many independent events as you want. It does not matter. You just figure out those probabilities.